So we are looking at Euclid Division Lemma question. So the question goes like this: show that every positive integer is of the form 2q. So here the keyword is every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1. So let's understand this question before we answer it. So what are they telling? So to understand that, we will use our program again. Here I have put the divisor to be 2, and I have considered number from 460 to 500. So if I execute this, the program will give me the reminders, respective reminders, and let's make an observation based on our output. So let's observe what is that we are seeing when we divide numbers with 2. Before that, why did I divide with 2? Why was the divisor 2? We saw the divisor was 2, right? I took it to be 2. But why did I do that? See, the reason being simple. Here the question talks about every positive even integer is of the form 2q and odd integer is of the form 2q plus 1. If you remember the Euclid Division Lemma we just studied in the other video, we saw that any number can be written in the form of divisor into quotient plus remainder. Is it not? So basically in the same pattern, if you look over here, the divisor is 2. Here too the divisor is 2, where q is your quotient, so the divisor is 2. That's why I took the divisor to be 2. So with the divisor 2, with the divisor being 2, and the all the possible integers from 460 to 500, including 500, the reminders are either 0 or 1, right? So between this set of numbers, I have taken all the possible integers, and we just showed that all of these integers have a reminder of either 0 or if they will have a reminder of 1. Either of this, they can have a reminder of 0 or 1. That's what the question is asking. But here they are asking not between 400 to 500. It's not between some numbers. It's the entire every positive even integer. So all the possible numbers. So they want a general statement, right? Another perspective, I have a few numbers over here, and these numbers I want to group them in this circle. So I'll put a condition that if I have a reminder 0 on dividing with 2, send them over here, and numbers with reminder 1, send them over here. So if I start classifying this way, I'll get to see that all the possible even integers on the screen will come over here, and all the possible odd integers will come over here. Is it not? Again, these are just few numbers, right? These are just countable numbers. But when we talk about every possible even integer and odd integer, we can't use a traditional way. I can't just pick certain set of numbers and tell that okay, this is what we are observing, right? That is not possible. Here we are talking about everything. So to prove things in this way, to prove things that we are considering all the possible numbers and this is what we got. To prove this, we need to make use of Euclid Division Lemma, right? Only then we will be able to solve it. So let's start by solving the question as per Euclid Division Lemma. Before using Euclid Division Lemma, we need to state what is Euclid Division Lemma. If A and B represent all possible positive integers right? So we'll put a condition that for A being greater than B, actually should have written it over there, where A is greater than B. This will erase. Right? As per Euclid Division Lemma, if A and B represents all positive integers, then A can be written as product of B into some quotient plus remainder, where remainder is greater than or equal to 0 but lesser than B. And Q, R are unique positive integers. Right? Let me write where, not and. Where Q and P are unique positive integers. This is a statement that you need to write. There are different statements that in the textbook they are given it in a different way. I have written it in a bit different way, but yes, both are right. For me, the language is simple. For me, again, it's for me, the language is simple, so I am following this. If you want to follow any other language from your teachers or from the textbook or any reference book or any internet, you search and you find something, whatever is convenient, provided it's right, that condition is there, you can write those statements. So for me this was convenient, a bit lengthy but convenient. So what did I write? So I wrote that A and B are all possible positive integers, where A is greater than B, then A can be written as B into Q plus R, so on and so forth. Right? So this is your general statement. But here, the thing which will change is, I'm substituting B is equal to, can you guess? 2. Yes, you're right. So I'm going to write A as 2 into Q plus the remainder, where the remainder is between 0 and 2, not including 2. This implies remainder is either 0 or 1. Is it not? Right? So let's just follow the maths now. Let's not think too much. Just let's follow the math. So we wrote the Euclid Division Lemma statement, and I'm putting B is equal to 2, and I'm continuing to write the answer. Okay. So now we'll take case when the remainder is 0. See, there are two possible answers, is it not? When the remainder is 0 or 1, right? There are two possible answers. What happens to this equation with these possible scenarios that we are trying to observe? We're just following the maths, nothing else. So here A will be equal to, 1 minute, here A will be equal to 2 into Q plus 0. That is 2 into Q. But we know that 2 into anything will be an even number. So this represents even number. So when we took remainder 0, that represented even number. Again, we're just following the maths. Don't think too much. Now the case when the remainder is 1. What happens to the equation? The equation will be A is equal to 2Q. Right? 2 into Q plus 1. So we know that this is an even number, plus 1, which is an odd number, will give me an odd number. Right? So basically we ended up with two scenarios, and one of the scenarios represents even number and the other scenarios represent all odd number, and A represents all the possible number, remember. So to conclude, right, the answer is still here actually. Then you have to write hence proved and stuff. But let me conclude before we end up writing the answer, complete answer. So if this circle represents all the possible integers denoted by A, then I can divide them into two groups. As per this, I'm dividing this into two groups. One is 2Q and another is 2Q plus 1, where 2 is your divisor. Right, that's what we showed. Mathematically we showed that. We told that okay, A, B, all the possible integers, and B is equal, we just took B to be equal to 2, and A got divided into two groups, right, when the remainder is 0 and 1. So when the remainder was 0, it gave us 2q, which was even number, right? And the other group was 2q plus 1, which was odd number. And thus we showed that every positive even integer is of the form 2q and odd integer is of the form 2q plus 1, right? You got it? So if you're still feeling a bit weird about this, you see few more questions and you'll get it. Hence proved. Actually the question is show that, so you need not even write this, but you know, sometimes the question is prove that and stuff like that. So it's better to make an habit of writing hence proved. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification calculation, DIY projects. We'll code with Python, we'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.